What's up guys, welcome back to my YouTube channel. In this video we're going to discuss another set of topic. So our topic in this video is adding rational expression with like denominators and subtracting rational expression with like denominators. So again, adding rational expressions with the same denominators or like denominators, and we have subtracting rational expressions with like or the same denominators. So we are going to give two examples for addition of rational expressions with like denominators and two examples for subtracting rational expressions with like denominators. So for let us start with addition of rational expressions with like denominators. So let us have, for the first example, 2x over x plus 2y plus 4y all over x plus 2y. So in this case, you are going to add two rational expressions. So here is the first expression, rational expression, and the second rational expression. So what you are going to do in adding rational expressions with like denominators or with the same denominator. So as you can see here, the two rational expressions have the same denominator, which is defined by x plus 2y. So let us not forget that to add or subtract rational expressions with like denominators or the same denominators, add directly or subtract directly the numerators and then copy the denominator. So meaning to say, when you are going to add, then simplify the result, of course. So meaning to say, when you are going to add rational expressions with the same denominator, just add directly the numerator, just like adding rational numbers, and then copy the denominator. Then don't forget to simplify if possible. Okay, so do not forget to simplify the result if possible. So say for example this one, 2x. So since they have the same denominator, just add directly the denominator, then copy the numerator. So 2x plus 4y, it will become 2x, it will become 2x plus 4y over x plus 2y. Okay, as you can observe, the numerator has common factor. So let us factor out 2. If we're going to factor this expression in the numerator, so we can have we can factor out 2. So we have 2 times x plus 2y all over x plus 2y. Okay, that's it. So for this case, we have the numerator x plus 2y expression, and we have x plus 2y in the denominator expression. So in this case, we can cancel out x plus 2y. Okay, so we have here 2. Since we already cancelled x plus 2y in the numerator and denominator, then the remaining term will be 2, or the resulting expression will be 2. So you can say that 2 is the result as you add the two rational function here, which is 2x over x plus 2y plus 4y over x plus 2y. Right? So just don't stop here in this part. You can simplify. Again, the rule said that simplify if possible. That is why we get 2. Okay? That is for the first example. Next, we have the second example. Say for example 10x over 2x plus 1 plus, or being added to 5 over x plus 2x plus 1. So in this case, we still have the same denominators to both rational expression here. So all you have to do is to get the, or just simply add the numerator, or get the sum of the numerator directly. So 10x plus 5 is equals to 10x plus 5 all over, just copy the denominator. You have 2x plus 1 since they have the same denominator, and then 10x plus 5 still can be factored out. So our factor can be, so let us factor out the numerator. So factored out 5 for the numerator, it will become 2x plus 1 all over the denominator, which is 2x plus 1 also. So as you can see, as a result of the numerator, after we factored out 5 in this expression, it becomes 5 times the quantity of 2x plus 1, and all over, copy the denominator, then since denominator and the numerator are all the same, then you can cancel out this one. Okay, so the remaining term of the expression will be 5. So you can say that by adding rational expressions with the same the same denominators, just directly add the numerator and then copy the denominator, add the numerator and then copy the denominator, and don't forget to simplify afterwards. Okay, so the result will be this one in this expression here. Okay, so that's all for the addition of rational expressions with like or the same denominators. Now let's move to subtracting rational expressions with like denominators, or subtraction of rational expressions with the same denominator. So let us have the first example. Say 3x over x squared minus 4 minus 6 all over x squared minus 4. Okay, so in this expression you are going to subtract or get the difference of the two rational expressions, which is 3x over x squared minus 4 and 6 over x squared minus 4. So as you can see to the rule, or as you can remember, the rule states that to subtract rational expressions with the same denominators, just simply subtract the numerators and then copy the denominator. The same rule with the addition of rational expressions with the same denominators. So you are just simply say, in this expression you will say 3x minus 6 all over, since they have the same denominator, just copy the denominator, x squared minus 4. Okay, so since we all know that the numerator can be factored out, and also we can get the factors also for the denominator, since it is the difference of two squares. So let us factor out numerator and denominator. So the factor if we factored out 3 in the numerator, it will result to 3 times x minus 2 over the factors for the difference of two squares. Here we have x squared minus 4 are x plus 2 and x minus 2. So these are the factors for the denominator defined by x squared minus 4. So we have x plus 2 and x minus 2. So as you can see, there is common between the numerator and denominator, which is the quantity of x minus 2. So you can cancel out x minus 2. Okay, so the remaining terms or expression is 3 over x plus 2. So 3 over x plus 2 is the simplest form of rational expression after we subtract the two expressions here, which is 3x over x squared minus 4 and 6 over x squared minus 4. So as we can remember that rational expression is already in its simplest form when denominators and numerators have no common factor other than 1 or negative 1. So this is now the simplest form after we add, after we get the difference of the two expressions here. So that's for number 1. Next, let's move for the second example of subtracting rational expressions with like denominators. Say for example, we have x squared plus 6x plus 5 all over x squared plus 3x. We have minus 10 minus x squared plus 4x minus 5 all over x squared plus 3x minus 10. So this one. So as you can observe, they have the same denominator. So as the rule states, we are just going to add the numerator directly. So and then copy the denominator. So we have, let us simplify first the numerator. So we are going to distribute the subtraction sign here in this expression. So x squared plus 6x plus 5 minus x squared minus 4x plus 5 all over, copy the denominator as what our rule stated, x squared plus 3x minus 10 is equals to, now in the numerator let us combine like terms. Okay, so we have x squared minus x squared, that is 0. 6x minus 4x, that is 2x. Again, 6x minus 4x, that is 2x. Then 5 plus 5 is 10, plus 10 all over. So as you can see with our denominator, it is a perfect square trinomial. So by this, we can factor out, or we can get the factors of this perfect square trinomial. So the factors will be x plus 5 and x minus 2. So x plus 5. So the factors are x plus 5 and x minus 2. So if you are going to multiply x plus 5 and x minus 2, the resulting product will be x squared plus 3x minus 10. So we just get the factors of this expression here, x squared plus 3x minus 10. Okay, let us proceed. Okay, so is equals to 2x. You can factor out also the numerator here. So since we can factor out 2, so we have 2x plus 5 over x plus 5. Our purpose here is to simplify the expression after we get the difference. So we are going to simplify this one to lowest term. So again, the rule stated that simplify after all if possible. So we have x minus 2. Since we have common here, x plus 5 and x plus 5 in the numerator, then you can cancel out this one. So the resulting difference of the two rational expressions will be 2 over x minus 2. Since this is already the simplest form of the expression, because the factors of numerator and denominator is 1, then this is already the difference of the rational expressions defined here. Okay, so considering that they have the same or like denominators. So that's all for this video, guys. Thank you for watching and for subscribing. Don't forget to subscribe for more videos and for more updates to my channel. That's all for this video, and God bless everyone. Bye bye.